Hello everyone, welcome to the lecture series of pattern classification. I am Kundan Kumar. If you would like to have the lecture slides, you may refer to my GitHub page at this given link. So, in this lecture, we will be solving a problem on linear discriminant analysis. Here we have given two set of feature vectors belonging to two different class omega 1 and omega 2. Here we need to find the best direction of line of projection that best separates the data in one dimensional feature space. So, here we are talking about the best data separability. So, we need to consider the class labels and solve the problem using the linear discriminant analysis. In this problem, we are seeking the direction of the line of projection that best separates the data in one directional feature space. So, here we can project all the data points on this line of projection, so that the separability of these data points will be the maximum, that will be the best separation. Now, let us solve this problem. So, in this problem we have given two set of feature vectors, that is d1 and d2. So, set of feature vectors of d1 belongs to class omega 1 and set of feature vectors d2 belongs to class omega 2. As we know that a projection line is given by y equal to w transpose x that passes through the origin that best separates the data point in one dimensional feature space if W equal to S W inverse into M1 minus M2, where SW is within class scatter matrix, where M1 is the sample mean of set D1 and M2 is the sample mean of D2. Now, we can calculate these parameters from the given set of samples. So, where M1 equal to 1 by N1, N1 is the number of samples in the set 1, and we will take the summation of all the feature vectors in set 1. So, when you will calculate, the value will come 4.38. Similarly, we can compute M2, which will be 1 by N2 summation x, where x belongs to set 2, and that will come 9.2, 3.8. So, these are the two mean values of these two different set of samples. Now, we need to compute the within class scatter matrix. So, how we can compute? So, as we know that within class scatter matrix is the summation of individual class scatter matrix. So, here S1 is the scatter matrix of class 1 and S2 is the scatter matrix of class 2. So, now we have to compute the scatter matrix of class 1. So, which is basically x minus M1 into x minus M1 transpose where X belongs to set 1. So, when you will solve it, so we can compute these parameters for the given set of samples in set 1. So, we can write 1 minus 4, 2 minus 3.8, and this is the transpose of the same value. So, 2 minus 3.8. Okay. Next, okay. So, this is the value. So, when we solve it, it will be 20, 10, 10, 6.8. So, in the same manner, we can compute the scatter matrix of S2. So, it will be X minus M2, X minus M2 transpose where X belongs to set D2. So, when you will solve this value in the same manner, you will get 168, 16.2, 16.2, 8.8. Now, to compute the within classes scatter matrix, we have to add these two scatter matrix S1 and S2. So, let us add scatter matrix S1 and S2 to compute within classes scatter matrix. So, we need to compute the inverse of the within classes scatter matrix, and that value will be minus 0.0069 minus 0.0116 minus 0.116 0.0836. Okay. So, now we need to compute the W. So, SW inverse into M1 minus M2. So, just put the value. Okay. Then so we can solve this matrix multiplication. It will be 0.036. Okay. So, this is the basically the direction of the projection line. So, this is not the normalized, we can normalize it, just we have to divide with the norm of the W vector. So, we will get minus 0.5115, 0.8592. Okay. So, now we can analyze this value. So, here we have set of data points from set 1 and set 2. So, we can draw this unit vector W in this plot. Okay. So, it shows that in this direction the separability of the data is maximum. So this is our solution. If you have any doubt, then you can ask in the comment section. Thank you.